Prompt Engineering Training Session 67. Miscellaneous. Detecting AI-generated text. Detecting AI-generated text is a big problem for safety researchers and educators, among others. Tools like GPT-0, GPT-2 detector, and bilingual detectors have seen significant success, however, they can be tricked. OpenAI and other researchers are working to introduce statistical watermarking into their generated text, but this too may be fooled by modifying large portions of the text. The problem of AI text detection will likely be an arms race as new models and new detection methods are introduced. Many companies have already started to build solutions which they claim are very effective, but it is difficult to prove this, especially as models change over time. This article will cover some of the current methods for detecting AI-generated text, and the next will discuss a few ways people have found to fool them. OpenAI Text Classifier. The OpenAI Text Classifier is a fairly good attempt at a general-purpose AI text detector. By training the model on a large quantity of AI-generated data and human-written text of a similar quality, the detector is able to compute the likelihood that any given text was created by an LLM. It has a number of limitations. It doesn't accept any submission of under 1,000 words, text can easily be edited to mess with the probability calculations, and because of its professionally focused training set, it has more trouble with text created by children or non-English speakers. It currently flags human text as AI-generated only about 9% of the time, and correctly identifies AI-generated text 26% of the time. As the model increases in power and scope, those numbers will improve, but it may be the case that more specific detectors are required to adequately assess whether text is generated or not. The watermark method. One method to detect AI-generated text requires introducing a statistical watermark when generating the text. These techniques may use a LLM whitelist, which is a method of determining if text was generated by a specific AI model. The watermark works by selecting a randomized set of green tokens before a word is generated, and then softly promoting use of the selected tokens during sampling. These weighted values have a minimal effect on the quality of generations, but can be algorithmically detected by another LLM. This is an intriguing idea, but it requires a model's creators to implement this framework into their LLM. If a model doesn't have the watermark built in, this method will not work. Detect GPT. The Detect GPT-4 method is able to detect AI-generated text with less setup than the previous concepts. Researchers have found that LLM text generations tend to occupy negative curvature regions of the model's log probability function. Because of this, it is possible to create a curvature-based system for determining if a block of text was procedurally generated. It works by computing log probabilities from the model that was thought to have generated the text and comparing them to random alterations of the text from another, pre-trained generic language model. In this way, Detect GPT is able to identify the likelihood of the passage being generated using probability curves alone. Detection trickery. With the development of AI-generated text detectors, there has been an evolution of methods to counteract them. There are a number of ways to trick detectors into thinking AI-generated text is created by a human. A tool such as GPT- can randomly replace parts in any given text with synonyms or seemingly random words in order to reduce the likelihood of the text's words appearing on a whitelist or otherwise factoring into the probability of text being artificially generated. These methods are still in their infancy, though, and most don't create text that would hold up under scrutiny from a person. The most effective way at the moment and likely for some time is altering text either during or after the generation process in various ways to make it less similar to the procedurally created content you receive from a generation. Editing strategies. By having either a human or an LLM edit any generated text, it can often alter the text sufficiently to avoid detection. Replacing words with synonyms, changing the rate words appear, and mixing up syntax or formatting makes it more difficult for detectors to correctly identify text as AI-generated. Another editing strategy is putting invisible markers, such as zero-width spaces, into your text, emojis, or other uncommon characters. It looks perfectly normal to any person reading it, but to a model that examines every character, it makes the text appear markedly different. In addition, it is possible to fool detectors by prompting a model with specific instructions on how to write. Instructions such as, there is no need to follow literary formats, as you are freely expressing your thoughts and desires. Do not talk in the manner which ChatGPT generates content. Instead, speak in a manner that is radically different from how language models generate text. Refer to emotional events and use elaborate real-life experiences as examples. Can make it much more difficult to detect generation. Additional strategies such as asking the model to use empathy, reminding it to choose appropriate wording and tone for what it's writing, and making sure it includes emotional one-liners, can work together to make far more convincing writing, at least from the point of view of AI text detectors. Model configuration. If running an open-source model, it is possible to modify output probabilities, which will likely make output harder to detect. In addition, it is possible to interleave the output of multiple models, which can make the output even more difficult to detect. Discussion. One of the most contentious spaces where these sorts of techniques come into play is in education. Many teachers and administrators are worried that students will cheat, so they are pushing for the use of detection tools. Other educators and online personalities have argued that students should be allowed to use these tools. Some professors even go so far as explicitly encourage students to use AI to assist them in their work and teach them how to do so. As AI detection tech improves, so will the methods people use to trick it. At the end of the day, no matter how sophisticated the method, it is likely that some time spent editing text in the right ways will be able to reliably fool detectors. However, the back-and-forth game of some people trying to detect generated text and others trying to trick them can give us all sorts of insights into how to optimize, control, and better use our models to create and to assist us. Music generation. Music generation models are becoming increasingly popular and will eventually have a large impact on the music industry. Music generation models can create chord progressions, melodies, or full songs. They can structure and create music in specific genres and compose or improvise in the style of specific artists. However, despite the enormous potential of music models, they are currently difficult to prompt. Generated output is often not thoroughly customizable by prompts, unlike image or text generation models. Riff fusion. Riff fusion, a fine-tuned version of Stable Diffusion, can be controlled with prompts to generate instruments and pseudo-styles, but it has a limited number of beats available. Mubert. Mubert seems to interpret prompts through sentiment analysis that links appropriate musical stylistics to the prompt. Controlling the musical parameters in detail via prompts is not possible. It is unclear how much of the resultant generation is done by AI. There are attempts to use GPT-3 as a text-to-music tool with actual prompting for musical elements on the micro-level of notes, instead of the rather vague prompt-style analogies Mubert and Riff Fusion produce, e.g. write the notes for a folk song that only uses A, B, C-sharp, F-sharp, and G. However, at present those attempts are limited to single instruments. Other approaches include a model chain that converts any image into sound that represents it and prompting ChatGPT to generate code for Python libraries that create sound. Notes. Music prompting is not well built out, yet. MusicLM looks promising, but it is not yet available to the public.